Hi friends, hope you are doing well. I'm Dr. Ganguly. Welcome to my channel. So today I'll be discussing an important question on career choice, and this is essentially between what is known as data analysis and data science. Now, many people at different points of their life, they think of taking these disciplines either directly in college or university through bachelor's or master's degree program, or you may be somebody who is working in some other sector. Maybe you have done your degree in engineering, computer science, social science, humanities, and you want to do a career change, and it's one of the simplest career changes which is out there, that you can essentially easily become a data analyst in case you are in some of the humanities and social sciences professions, and you can become a data scientist if you happen to be an engineer or scientist or a computer scientist for that matter. So let us look at these career choices or these disciplines and how to get into them. So before I even begin this thing, I want to motivate you by telling you some of the salaries involved here. So typically a data analyst in the US gets a salary of about 90,000 US dollars, and a data scientist gets a salary of about 125,000 US dollars. So these are pretty high salaries, and wherever you are in the world, the salaries will be correlated in some proportion to these salaries. So first let us take a look at the data analyst type of job, and this is also sometimes known as a business analyst, because most of the time the people here are using data for some kind of business process. So essentially we can define it as a statistical study of business data to obtain insights. Now you know that businesses have a plethora of data available with them, starting from your name, your gender, the area you live in, the age, and your income level, sometimes your credit score, and then your predilections in terms of different things you charge at different places on your credit cards, your banking transactions, maybe even the amount of money which is there in your savings account, checking account, fixed deposits, and so on. The car you drive, the house you stay in, the value of your house, what are your general predilections toward tourism, and so on. So essentially for any given person there is a huge amount of data available out there, and the businesses want to make sure that they tailor their offering to you in terms of data. So essentially in this business type of mindset, you have mostly what I would call as structured or processed data. So essentially this data is in a very clear format. So for example, if you're looking at the age of a person, if you're looking at a credit score of a person, if you are looking at the location where they stay, these are essentially numbers. In some cases they can be integers, in some cases they can be real numbers, and in some cases these may be yes or no type of Boolean type of situation. So that's also possible. So what you need to handle this kind of data is mostly statistics, and generally people who use statistics tend to use Excel, and then if they get very well versed in Excel, they may need to write programs, and then these programs are typically often written in R. Now lately of course Python has made its entry into the Excel system, but we will leave that aside for now. I would say that as far as most data analysis work is concerned, it can be conducted in R. The person doesn't have to do too much low level coding. R is a high level language, so you can accomplish a lot of statistics by using this language. Now let's think of some of the problems which you may solve in this particular line. For example, you may need to answer who is to be given a loan by the bank, who should be given a mortgage, who should be targeted for marketing, which person is likely to choose which airline, should you be given a credit card, is there a fraud in a credit card transaction, and so on. So most of the jobs out here are in finance, healthcare, retail, travel, insurance, supply chain, and also communication. So essentially most of the time the business analyst type of course or the data analyst type of course is often given by the business management departments at universities, or what are known as the management department. So most of the time management departments may even have a business management degree with a specialization in data analytics. They may have a master's degree in this field, and sometimes people can even do a PhD in this area. So again, here I would say the mantra is that it is more of statistics, less of coding, more of R, Excel and Tableau, less of very deep Python, pandas and so on. Now let's start to look at data science. Now in data science, what happens is that you not only use statistics in looking at data, but you also use a lot of algorithms. And one of the reasons is that the data now is actually not present to you in a very structured or processed format. So you don't have nice data in the form of tables of people's age or their credit score or their net worth or maybe their gender and so on. Instead, what you have is a huge amount of matrices which are coming at you. For example, think about a self-driving car situation. So essentially this car is taking measurements through videos, and this information is being communicated to you at very high speed in real time, and you need to make decisions based on that. Similarly, if you think of face recognition software which is out there throughout the world now, cameras are recording people, and so a lot of these matrices are coming in. These are essentially pictures, and so through these the AI system is able to figure out if any person is there in any location. So these kind of software or these kind of AI type of things which has started coming in different movies also is typically a product of data science, and AI and machine learning are becoming very important here. So I would say raw unstructured data is often present in data science. You have to do a lot of time in data cleaning. Now data cleaning here may involve aspects of signal processing, whereas when you were handling business data it was mostly about removing outliers and also replacing outliers by certain values. Now feature extraction becomes very important in data science. So you may have a very large amount of data and you may need to condense this to extract features from it. You also need to know a lot about coding here. So you may certainly need to be pretty much of an expert in Python, in pandas, and Python has a huge amount of libraries such as scikit-learn and PyTorch, which can help you do machine learning and even deep learning. And at the very basic level you have NumPy and SciPy, which lets you do a lot of the scientific and mathematical operations. Now pandas also lets you do a lot of statistical issues and problems, and also you need to know SQL as far as both data analysis and data science is concerned, because this is the language which lets you get data from large relational databases, and many a time SQL can actually be faster in most computing systems than pandas. So that is something to keep in mind. Now you need to know a lot of math in data science. For example, you need to know linear algebra, you need to know calculus, and you need to know probability and stochastic processes, because many a time the analysis which you need to do with data does involve not only knowledge of statistics but also probability, various deep aspects of probability involving Bayesian networks and so on, and also you need to know stochastic processes, so you exactly know what are things such as the law of large numbers, Markov processes and so on. So these things become important in data science. So now you can see that people who have done engineering or science degrees, they often have taken these kind of courses, and therefore it's quite easy for them to figure out the math aspects of data science, but where they struggle is in the computing aspects of data science. Now, data science can of course address business issues, but often it tries to address issues which are more related to engineering and computing. So like I mentioned, if you are planning a self-driving car or a self-driving truck, or you are planning face recognition software or fingerprint software and so on, then essentially these are really engineering problems and the solutions are engineering solutions. So I would say this is a mixture of engineering, computer science, mathematics, and data analysis. Now, of course, a lot of this can be used for any kind of business decision making problem. If you have, for example, raw data, unstructured data, data scientists can perform a good role here. And of course, any problem which can be done by simpler means can always be done by complex means. But why would you bother to do that? You don't need to actually hire somebody with intricate mathematics skills if you can get this work done by somebody who has less of math skills but more of business skills. And that is why there is a clear demarcation as well as things are concerned. If you see the various jobs out there, the jobs out there in various healthcare companies, in insurance companies, in finance companies, they may say they are data science jobs, but actually if you peruse further, they are more like data analysis jobs. So people are using these names with no fixed thinking in their mind, but as far as academia is concerned, it has split these things very clearly, as data science is much more math intense and data analysis is much less math intense. So of course, do remember that in any case where you have to do a lot of programming, you can take the help of ChatGPT to ease your life, because ChatGPT can write various programs and subprograms in languages such as Python and R. And also remember that you can easily get access to Python and R through Jupyter Notebook, and this is free. You can download this in your computer. So if you search around in YouTube or Google, you will find a lot of information on Jupyter Notebook, and you can quickly start programming in R and Python just to make sure that you have some marketable skills in case you want a quick job. So again, to recapitulate, if you are in the social sciences and humanities background and want to break into the high paying jobs in these areas, then data analysis is the way to go. And if you are somebody who is an engineer or scientist and is attracted to looking at the world as a collection of matrices, then you can enter this matrix through data science. So I'll end this video now, and I will see you in a video sometime soon. See you then.